For the next few moments, I want to showcase some of the innovative CAE technologies that we have introduced in MSC Apex. Let me first import a model. As you will note, we support a number of geometry types. We have an assortment of tools dedicated to geometry and mesh editing. Here, for example, I will extract the mid-surfaces of the model. This tool, like every other tool in MSC Apex, is easy to use and easy to learn. Each tool you encounter is complemented with narrated video tutorials and instructions. Say I would like to remove some features. I click on the Defeature tool and become familiar with the tool by using the narrated video tutorial and workflow instructions. Once done, I know how to use this tool. The particular tool can be used in the point and execute manner, or I can select numerous features to remove at once. Let's go ahead and mesh this model. A look at the mesh quality reveals some poorly shaped elements. No worries, I'll simply select on the geometry and move it until the quality of the mesh is improved. And we can do this because the CAE specific direct modeling and meshing technology available in the application. With each change in the geometry, the mesh is regenerated. I will assign a material and selection behavior to this example. If we refer back to the original solid model, each part has a different thickness. Our resulting mesh model must reflect this. You would traditionally have to define and assign each thickness property one by one, but in MSC Apex, the process has been automated. I have meshed and applied material and section properties to this particular part. Before moving up to an assembly and an entire analysis, I should make sure that this particular part is ready for analysis. I can do a quick check to spot any problems in just this part that may prevent a successful analysis. And we can do this because the application is integrated with solver methods. A quick check shows that I have neglected to assign a material. I remedy the problem, and a recheck shows that the model is ready to be analyzed. This is one part of many that must be ready for analysis. I can continue incrementally building my assembly, each time ensuring that the part is analysis ready. In some scenarios, the mesh may be inadequate, but the direct modeling and meshing capability allows me to quickly modify broken geometry. One cool thing about MSC Apex is that it is generative. A small change, such as a mesh modification, has rippling effects so that the changes cascade down to any dependent object, such as properties and boundary conditions. Once each part has been validated, I'll connect each part to form my assembly. We'll make sure that the assembly is analysis ready, and it is. Now we can perform an analysis, and you'll notice we analyze the assembly successfully on the first try. Now how can this get any better? Here, I'll make a small change on this part. Say I change the size of this hole. I'll perform a quick analysis of readiness, and once I get confirmation that the model is ready, I reanalyze the model. We have introduced computational parts technology in MSC Apex that allows us to incrementally solve assemblies. The history of the previous analysis is kept, and only what has changed is recomputed. This is why the second analysis took a fraction of the time, because only one of the parts needed to be incrementally solved. Once done, I can export my geometry and my mesh into Parasolid and BDF file type, respectively. To summarize, we have seen how MSC Apex features integrated analysis capabilities, expedites run-ready parts and assemblies, how the generative behavior of the application requires minimal edits on the user end, and how computational parts technology contributed to an incremental solve paradigm that makes it possible to analyze large assemblies in a fraction of the time. Thanks for watching.